Hello and welcome to Sonaca, Gosselies, close to Charleroi. Sonaca is an aerostructure tier 1. Tier 1 meaning that we provide our products mainly to the major OEMs of the aerospace sector. The biggest part of our revenue is actually in the aviation, so aircraft. So we work for all the big guys like Airbus, Boeing, Embraer, Bombardier and so on. For those guys we do design and produce in series the components of the aircraft. But next to that we are also active in the space sector, in the space market, and that's why we are interested in this additive manufacturing challenge. So in the space market we actually work on satellite structures, satellite panels if you like, that we complete with sensors, with a thermal management system and so on. Also design and production of those elements. We also work on space launchers structures, and we do those activities for, here again, all the major actors in which NASA, ESA, Ariane Group, OHB, Thales Alenia Space and so on and so on. So a very exciting sector with a lot of technical challenges, among which one of them that Alexandru is going to talk to you about.
Sonaca's purpose is to become once again the pioneer in the Belgian space market. In order to stay on the cutting edge and in order to meet the strict requirements that are related to space applications, we need to strive daily to produce technologies that will spearhead the design of tomorrow's satellite. Amongst these technologies, the ones related to the solar panels are the most usual ones. If you think about the storage space of the rocket, which is limited in size and it must be somehow strictly managed. And if you think about the solar panels, which by definition are large in size, then you reach the conclusion that these solar panels must be retracted during the launch phase. The ideal solution must facilitate the retraction of the solar panels during the manufacturing, must maintain the solar panels retracted during the launch phase, and must be passively activated in orbit based on an environmental trigger. These systems must be sustainable, cost-efficient, and they must not contain any electrical components. We are expecting a proof of concept. We will not test it in space conditions, of course, but it should prove that it can retract, stay in its position, and then, based on an external stimulus, extend. The Sonaca team will support the students by offering access to technical expertise as well as in financial subjects that will enable them to compare the rentability of the proposed variants. We will also offer constant communication with the student team, so we will be able to steer the direction that each of the team goes and be able to steer them back in the right track if something happens. We will be able to take them through a tour of the Sonaca factory here in Gosselies in Belgium, and this will help them to figure out what design for manufacturing and design to cost means, so what it means when you're designing components with your mind on the sustainability of the product, on the entire life cycle of the product. So students, are you interested in looking up and thinking that some of that satellite systems will be made by you? Then please choose Sonaca in the AM Challenge registration form. We look forward to welcoming you on board.